In this session, we are going to understand what is a relational data model. Okay? Relational data model. Just understand this. When we were talking about entity relationship model and we were doing conversions from entity relationship diagram into a set of tables, we were basically converting an entity relationship model into a relational data model. Okay, so in a relational data model, we represent a real model into a collection of relations. Collection of relations. Okay, by relation, what I mean is a table. Relation is equivalent to a table. Okay, so in a table, let's assume this is my table. It has some columns, okay, and it has some rows. So let's say I have a column 1, I have a column 3, 1, 2, 3, 4, 5 and 6, okay, and I have rows. In a table, a column represents a attribute. Okay, and a row represents a record. This record can be an entity, it can be a relationship. Okay, now let's define this row, or for that matter any row in a table is given a name, and that name is tuple. Okay, in simple words, tuple is a row in a table. Now next, in a relation or a table, the order of rows is irrelevant. Irrelevant, okay? This is the keyword here, because I say relational data model is a collection of relations, and a relation is a collection or rather set of records, and these records are rows, and rows are tuples. These all are the same things. Okay, and since this is a set, order is not important. Okay, so we have a relation named person, then we will have say name, we will have say PAN card number, we will have say address. Just 3 values. Okay, let's do this in the same color. Okay, now in this we have Jimmy. Okay, and number is say whatever AFP 1 2 3 and address is XYZ PQR. Okay, so this row represents an entity. Okay, this row represents person having name equal to Jimmy, PAN equal to AFP123 and address equal to XYZ PQR. Right? This is equivalence. Okay, this thing is in relational model, this thing is in entity relationship model. Okay, now we will look at a concept called the degree of a relation. Degree of a relation. It is also called the arity of the relation. Arity of relation. Okay. The degree or arity of a relation is equal to the number of attributes in the relation. As simple as that. So, what is the degree of this relation? This relation has a name person, by the way. Okay. So, what is the arity? Since we have 3 attributes, we have arity equal to 3. Next, we will revisit the concept of domain. Okay, we've already done this. We'll define it again. Domain is the set of permitted value for an attribute. Okay, so here I say the domain of PAN is a 6-letter string having first 3 digits as alphabets and next 3 digits as numerics. So in this way I specify that PAN card would be of this form: A to Z, A to Z, A to, okay, let's write it here down below. So for the PAN, I say the domain is, it is a 6-digit string. Okay, and these digits are such that first digit, or rather first place, is having alphabets, second place is having alphabets, third place is having alphabets, and last 3 places have numerals. So this way I restrict the possible values that PAN can take. It cannot have 1, 2, 3 A, P, Q, right? It cannot have 1 P, Q, 2, 3 L. It can have A, P, Q, 1, 2, 3, because I've already told you the domain is first 3 alphabets, last 3 numbers. That was about the domain. So now we will look at the constraints that we have on a relationship. Sorry, it's not a relationship, it's a relation or a table. So the first constraint is the domain constraint. I've already talked about what this is. It allows me to restrict the values that I can have for an attribute in the table. That is, for in any particular row, I can restrict the values that a specific column in that row can have. I am restricting the values over here. Domain constraint, that is done. Next constraint that we have is the key constraint. This is basically the same as the primary key. It tells me that no two keys may have same values. Okay, there should be no two tuples having the same value in their primary key. So I have a table. Okay, this is my PAN, this is my name, and this is my address. That's the table. Okay, there are, say, 3 rows in my table, and the first value is AFP 345. The name is, say, Joanne, and the address is XYZ PQR. I say that PAN is my primary key. Okay, so as per the key constraint, I cannot enter another row in this table which is having the same primary key. If I do that, then my database won't allow me to do that. I cannot do that. There is no question of if I do that. Okay, not possible. The next constraint is the entity constraint. Entity constraint tells me that my primary key cannot be null. Primary key cannot be null. Okay, so I enter a new value over here with PAN null, but this is not possible, right? That is the entity constraint on the table. So even this is not possible. Why is it not possible? Because primary key helps me to identify a particular concept in a table, right? It's gonna help me identify a particular person. Now if the primary key of that person is null, if I don't have his PAN number, I'm not able to identify this person. That is why a null PAN number is not permitted. This thing is called as entity constraint. The other constraint that I have is referential integrity. Referential integrity. Okay, referential integrity. Cannot understand this. Let's revisit our relationship, which was person owns a pet. Okay, just for the sake of simplicity, we will assume that this has the primary key as PAN and this has the primary key as the name of the pet. Although this won't be possible, but just for the sake of simplicity we are assuming all the pets have different names. Okay, so when I create a table corresponding to the owns relationship, I would have, and this owns has a relationship attribute brought home date. Okay, so when I create the relationship, or rather the relation, when I create the table of this owns relationship, I will have the primary key of the entities which are participating in the relationship. Okay, since this is, say, 1 to n relationship, many pets to one person, I will have the primary key as the name of the pet. Okay, so I will have my name of the pet, and I will have in owns the brought home date, brought home date. Okay, and obviously the primary key of this owns relationship is name. We've already talked about this. Let's also assume we have a pets table which is like this. It has the pet name, which is the primary key, and some attributes. I don't care what those are, and we have some attributes. Now my referential integrity says that whenever I enter a value in this table, this primary key of the entity which I am having here, which is my pets entity, whenever I enter a name over here, CC, there should be a corresponding entry in this table as well. Okay, if I have only two values, CC and Bruno, and I try to enter, say, Tommy in here, then this is not permitted because it is restrained by my referential integrity. Now this key is known as foreign key. Okay, because look, this name is basically connected. The name is connected to the name of the pet. So the primary key of the entity which is used in the relationship table is known as the foreign key. So foreign key is the name. Okay, now let's understand what else my referential integrity specifies. It says that the domain of name in owns, okay, let's say this is owns and this is pets. Domain of name in owns is equal to domain of name in pets. Okay. And the other thing that it says is the value of name in ounce can be either null or some value in pets. Okay, so this is the concept of referential integrity. I'll just write it down here. Referential integrity specifies these two things. The domain of the foreign key, which is a primary key in some other table, is the same as that of the primary key, and the value of the foreign key can be either null or the value of the primary key in another table should be the same. The value of foreign key should be the same of some value of primary key in other table. And the final constraint that we have, just understand, let's suppose we increase the number of rows in this table. If I have a value null over here and brought home date say 27th Feb 1995, then this would be allowed, because I already told you the value can be null or it can be one of CC or Bruno or whatever we have in the pets table. So that was about referential integrity. I'll talk about integrity constraints now. Integrity constraints. Integrity constraints. So we had referential integrity. I'll rather write it down in green so that I just maintain the order. Okay, it is referential integrity. Sorry, it is integrity constraints. Integrity constraints. I've already talked about what this is, right? These are the constraints that we have in the real world and we want to model in our relational model or ER model or whatever model we are using. So let's say we have pets table, okay, and in the pets table we have the pet name, we have the pet species, we have the pet breed. Okay, so integrity constraint allows me to specify, let's assume only dogs and cats are allowed to be have as pets. Okay, one can only have either a dog or a cat as pet. So this condition I would specify via an integrity constraint. I would say that value of species is equal to dog or cat. Okay, so now if I try to fill this table, like this: CC cat, a Persian cat. Okay, would that be allowed? That would be allowed, right? Because I already told you the value of species either dog or cat. Now I try to fill Jojo, which is a snake, and its breed is python. Is it possible to do that? No, because we have an integrity constraint which tells me that snake cannot be a pet, right? We had a constraint, integrity constraint, telling me we can have only dog or cat. So this kind of modeling is done via an integrity constraint, and that serves as a constraint on the value of a particular attribute in a particular tuple.